Hello everyone. Today we are going to discuss about the session 12 of chapter 3, it's semester 3 chemistry paper 3 of BSc chemistry syllabus of Colombo University. This is actually unit 1 analytical chemistry chapter 1, and it includes the instrumentation and application of zone refining technique. The learning objectives of this session is to learn the instrumentation and applications of zone refining techniques. The session outcome of this session is to understand, the students can understand the instrumentation and application of zone refining techniques. Zone refining is a process in which the impure metal is heated with the help of a circular heater at one end of the impure metal. The metal zone is moved forward along with the impurities and reaches the other end and is discarded. So as we have discussed in our previous session, different component of mixture are differently adsorbed on the adsorbent. Then the impurities are concentrated at one end of the block of metal so that the rest of block is purified. The impurities of low boiling metals can be separated by distillation, and the pure metal recrystallizes out of the melt. The instrumentation includes, in the zone refining process, a circular mobile heater is fixed at one end of the metal rod, which is made up of impure metal. You must be mention here that it is very important to note that it includes the circular mobile heater fixed at one end of the metal rod, which is made up of impure metal. The circular mobile heater is moved slowly across the metal rod, and the metallic impurities melt at temporary position of the heater. The melt containing the impurities move forward along with the heater through the entirely through the metal rod. Okay, the metallic impurities melt at the temporary position of this heater. The melt containing impurities move forward along with the heater. Okay, and the pure metal is left to solidify as the heater moves along the rod. As the heater moves forward, the concentration of impurity in the melt increases. Because of the impurities are more soluble in their corresponding melt state, finally the impurities are accumulated at one end of the metal rod, leaving behind the pure metal. Okay, the experimental setup is as shown below. Here you can see that this is the metal rod. Okay, and this is a heater. There will be a heater, and this is the circular metal, okay, which carries the mixture of metals along with the impurities along this metal rod. And you can see that at one end here there is a recrystallized metal, okay, and the impurities will be carried through the metal rod while heating this metal rod. Okay, so let us once again look at the instrumentation and explanation of this. In the zone refining process, what happens is the circular mobile heater is fixed at one end of the metal rod, which is made up of impure metal. Okay, it is as shown here. This is the circular metal. Okay, and the circular mobile heater is moved slowly across the metal rod. The metallic impurities melt at temporary position of the heater, and the melt containing impurities will move forward along with the heater. Okay, so that means the pure metal will solidify here. Okay, and the impurities are carried from here to here along with this circular heater. Okay, so this is a metal rod, and here it will be molten, as we have discussed earlier, that the you know there will be a difference in the solubility of the substances. You can see that the pure metals will have more solubility in the molten state, so that they can be easily separated out by this zone refining technique. Okay, as the heater move forward, the concentration of impurities in the melt increases because impurities are more soluble in their corresponding melt state. Okay, finally impurities are accumulated at one end of the metal rod, leaving behind the pure metal. Okay, so that can be seen in this experiment. And let us look at the applications of zone refining technique. It is used in the purification of organic compounds, and it is used to get the purest form of the elements, and it is used to remove the impurities in the semiconductor, and it also been used in the formation of a single crystal layer, and it is used to prepare the chemical standards for HPLC experiment, and it is also used in the standardization of calibrating instruments, and in the concentration of heat labile biological materials in aqueous liquids. Okay, just let us recall the applications. It is used in the purification of organic compounds. It is used to get the pure form of the elements, and it is used to remove the impurities in the semiconductors. It is used to form single crystal layer. It is used to prepare chemical standards for HPLC, and it is used for the standardization of calibrating instruments, and it is used in the concentration of heat labile biological materials in the aqueous liquids. Okay, in summary, we can understand that the zone refining is a purification process. In zone refining process, circular mobile heater is fixed at one end of the metal rod, which is made up of impure metal. As heater moves forward, the concentration of the impurities in the melt increases. The impurities are accumulated at one end, leaving behind the pure metal. Okay, so the impurities will be accumulated at one end of the metal, leaving behind the pure metal. So that can be seen here. Okay, so this is molten zone. That means the impurities will be melted and dissolved here, and the metal which is recrystallized at one end, and the impurities along with the metal which is carried through this metal rod by this circular heater. Okay, now let us look at few multiple choice questions which are included here. That is, the first question is, in the zone refining process, dash is used. The options are A. Thermostat, B. A coolant, C. Circular mobile heater, D. Boiler. Obviously, the answer is C, that is circular mobile heater. We can explain this in this way. In the zone refining process, the circular mobile heater is fixed at one end of the metal rod, which is made up of impure metal, and the circular mobile heater is moved slowly across the metal rod, so that the pure metal is separated by the impurities. Okay, The second question is, in zone refining, impurities are more soluble in dash. Option A is their corresponding melt state, B is plasma state, C is solidified, D is gaseous. And the answer is their corresponding melt state, that is option A. As heater moves forward, the concentration of impurities in the melt increases. It is because the impurities are more soluble in their corresponding melt state. Okay. Next question is, the zone refining is applied for dash. So you have the options here. A, purification of organic compounds. B, to get the purest form of elements. To remove the impurities in the semiconductor. D, all the above. The option is all the above. Okay, because as we have discussed earlier, it is used in all these processes, that is purification of organic compounds, to get the purest form of elements, to remove the impurities of in the semiconductor. Okay, now let us just recall once again the explanation for the instrumentation. That is, zone refining process includes a circular mobile heater which carries the impurities along with the metal rod, and it is the circular mobile is moved slowly across the metal rod so that there will be metallic impurities melt at the temporary position of the heater, and the melt containing impurities moves forward along with the heater through the entire metal rod. Okay, and the pure metal is left solidify as heater moves along the rod. It is as shown in this figure. That is, as heater moves forward, the concentration of impurities in the melt increases because the impurities are more soluble in their corresponding molten state. Finally, the impurities are accumulated at one end of the metal rod, leaving behind the pure metals. Okay, so here you can see that the melt of impurities will be dissolved and the pure metal is separated out. Okay, so this is the circular metal here, and this is recrystallized metal, and it is carried along with this metal rod. Okay, let us just recall the applications also. It is used in the purification of organic compounds. It is used to get the purest form of elements. It is used to remove the impurities in the semiconductor, and it is used to form single crystal layer, and it is used to prepare the chemical standards for HPLC, and it is used in the standardization of calibrating instruments, and it is used in the concentration of heat labile biological materials in aqueous liquids. In summary, just let us once again recall, zone refining is a purification process. In zone refining process, circular mobile heater is fixed at one end of the metal rod, which is made up of impure metal. As the heater moves forward, the concentration of impurities in the melt increases. The impurities are accumulated at one end of the metal rod and leaving behind the pure metal. Okay, so here for the first question, that is in the zone refining process, the circular mobile heater is used, and in the zone refining, impurities are more soluble in their corresponding melt state, and zone refining is applied for purification of organic compounds, to get the purest form of elements, to remove the impurities in the semiconductors. Okay, so these are few references that you can go through. The first textbook is Introduction to Instrumental Analysis by R.D. Braun, and the second reference you can go through is Instrumental Method of Chemical Analysis by B.K. Sharma, and Analytical Chemistry by G.D. Christian and J.E. Huey. Okay, that is Inorganic Chemistry Principles of Structure and Reactivity, and Vogel's textbook of Quantitative